Now, solving exponential equations. Exponential equations are equations where one of the exponents is or has a variable. So notice here's an exponential equation. The exponent is n, okay? The idea behind solving an exponential equation is when the powers of each side have the same base. So if you know a to the x equals a to the y, well notice they have the same base. The base to the left is a, the base to the right is a. So if this is true, then the exponents must equal each other. That's the whole theory behind solving exponential equations, right? So on your study notes, if you write if that equals that, then that equals that, that's kind of a summary of today's lesson. There's nothing to get excited about, really. It's just writing both sides with the same base and then equate exponents, and that's it. Ah. Interesting. Okay, so the base over here is 3. The base over here is 81. What do we need to do to get the left side and the right side to have the same base? What base should we aim for? 3, right? So if this is 3 to the 2x, how could I write 81 with the same base of 3? 3 to the 4, okay? So if I know this equals this, then right away I know 2x equals 4. And that means x equals 2. Cool, eh? Yay! Okay, so here we have a base of 5. Most likely we need to write this as a base of 5. I wouldn't want to write this as a base of 125. That would make it crazy, right? So we'll write that with the base of 5. So what would the base of 5 be if it's 1 over 125? Yeah, it would be 5 to the negative 3. Right? Because 5 to the negative 3 equals 1 over 5 to the 3, and that equals 1 over 125, right? That's all. Okie dokie. So now, because that equals that, the bases are the same, we can equate exponents. And the rest is redundant solving for x. Excuse me, rise and shine. Can you tap him on the shoulder? He needs to wake up. Thank you. Oh, you know what? If you don't feel well, put your head down. Huh? Did I make a mistake? Oh, thank you so much. Thank you for pointing these little boo-boos out. So my answer's wrong, isn't it? So it's 2x minus 1. So 2x equals negative 3 plus 1 is negative 2. So x equals negative 1. Okay, let's keep, oh, it's getting harder. But that's okay, you can handle it. This is a base of 36, and this is 1296. Do you think we could write that as a base of 36? 36 squared, awesome. Okay, so we have, what's that? I heard nothing. Huh? Did he? Wow. So far, so good? So this is going to be 36 to the 2x plus 4. And this is going to be 36 to the 2x to the half, right? So you have a power to a power. You multiply the exponents. 2x times the half is x. So we have 36 to the 2x plus 4 equals 36. So that's just x. So let's continue over here. So we have 2x plus 4 equals x. I'll move x over here, I'll move 4 over there. So subtract x from both sides, you get x equals -4. Do you need an extra step there? If you need an extra step, I'll put it here. That would be x plus 4 equals 0, and then, yeah, if you need an extra step. Okay, does anybody have any ideas on this one? What should we do? We have 2 to a really big exponent, x squared plus 2x. Sorry, chit chat, chit chat. Hello? Anybody? Well, don't we want to express that with the base of 2? Oh my. No, because 2x minus x is x. 2x minus x is x. Yeah. Good, I'm glad that's, yeah, any little thing like that that's throwing you, always check on it because that can really throw you off, right? It's easy to do. So this is 2. I mean, it's easy to make those, you know, to get kind of wondering where the number came from. So just ask me. This is x squared plus 2x equals 2 to the minus 1. Okay, so you have an equation. The bases are the same. So we can equate this exponent with that exponent. So we'll end up with x squared plus 2x equals -1. X squared plus 2x plus 1 equals 0. Whoa! A quadratic. So remember how to factor for this test. This is the same as x plus 1 times x plus 1 equals 0. So you know x equals -1. Now I realize we did this before in a previous unit. Is there anyone who needs to see an extra step? This is a perfect trinomial square. When you recognize it, you know it's easy to factor a binomial times a binomial, and x equals -1. Uh-oh. Did everybody see that? Am I moving too fast? Okay, more complication. Any ideas on what we could do? What should we do? We're going to have to somehow bring this together, right? Is there... Do we have a common factor? Yeah? 4 to... Okay, so let's take out this common factor. That's an important trick for you to know. So 4 to the 3 is, let's see, 4 times 4 is 16 times 4 64, right? Yeah? So 64 plus 1, 4 to the x times 64 plus, I'm just going to show a lot of steps because some people need the extra steps. So we have 4 to the x times 65 equals 260. Now what do we do? Divide by 65. So we get 4 to the x equals 4. You realize that 4 is just 4 to the 1, right? So what does x equal? There we go. Can I explain anything better? Okay. Feel free to ask any anything that's throwing you off, okay? I don't want you to hold back. Okay. Now what do I do for f? Sorry? Yeah, the only thing is this is 9 squared, that's 9, and this is 9 times 3. So I don't think 9 would be the base. We'll use 3, right? Because we have to get the same base for all 3 items here. So 9 is 3 squared times x plus 4 to the exponent x plus 4. 27 is 3 cubed to the exponent x minus 1, and that equals 3 to the 4. So we're going to have to go 2 times that, and 2 times that, and 3 times that, and 3, because we have to distribute, right? So it's going to be 3 to the 2x plus 8 all over 3 to the 3x minus 3 equals 3 to the 4. So what we did is we write everything with a base, that should be a e, of 3. So now what we can do is simplify this. You know, you could multiply both sides by 3 to the x minus 3, but let's just subtract. So we have 2x minus 3x is negative x. 8 minus a negative 3 is 8 plus 3, so that's plus 11 equals 3 to the 4. So here we have our equation. We have the same base on both sides. Now we can equate the exponent. It's negative x plus 11 equals 4. Negative x equals negative 7. X equals 7. I guess, do you want to do tomorrow's lesson today, or should we just wait for tomorrow? Wait? Okay. We can wait, whatever you want. That's all, folks, unless there's anything I can clarify.